Great to be here. Nice to see you all. I don't know if this is a confession or an acknowledgement before I start, but at about 1:30 this morning, when I was like, Ted's going to kill me if I don't get him some slides soon, I was still forming opinions about this topic. And my opinions might be different at the end of the talk compared to where they are right now. I think that's just where the space is. And I also have the luxury of no one gets to ask me any questions because when I get to the end, we're going to go into a panel. And so I can just redirect your questions on my spicy thoughts to other people, and I don't have to actually take responsibility for any of them. So with that, I'm going to jump right in. So CircleCI, we're in the middle of the software delivery lifecycle. I think we're all here because the software delivery lifecycle is changing in ways that we probably never imagined. And we think about this as a provider of tools in this space. We think about probably 4 different things when we think about AI. So I want to talk a little bit about each of those, spend most of the time, which is a good way to point back there. There we go. Oh, okay. Is there maybe a battery issue? Which way? Oh, I don't thank you. So 4 things. What's the best way to point? Where's the receiver? Okay. I'll guess. It's AI. Number 1, internal productivity. We're software developers, so we think about how we can deliver software effectively. We're also selling products to software developers, and so it's very important to us to think about being our own best customer, right? You start companies to scratch your own itch a lot of the time, and in 2011, when CircleCI was started, we knew a lot about delivering Rails apps to Heroku. That's not who our customer is anymore, and our customer is changing really rapidly. So we think about our own delivery, and then we think about what that means with respect to our customers. Then there's better developer experience. How can we change our product offering in a way to help developers who are doing what they're doing today do that better, do that faster, give them faster feedback, give them better information about what it is that they're trying to do, right? So our product is going to be improved by our leveraging of generative AI. Then we have new customer goals. Our customers are building products leveraging generative AI. There was just a whole discussion about evals and testing and what are they trying to do to feel confident in the products that they're delivering on top of our platform. And then finally, everything is changing, right? The entire software delivery lifecycle is changing, so what is our role as a provider of tools in that world? So we have really, we say AI as a sort of an umbrella, but we're really thinking about 4 different things when we talk about that. So on the first one, internal productivity, I don't know why I'm having so much trouble with this, but I'm just going to keep guessing. There we go. I don't know who's familiar with this bell curve meme. I can't unsee it now that I've seen it. I see it in like everything that I look at. And I actually think this is, I've been talking to a couple folks today, and Deepak was talking about sort of like the super junior developers being the first to adopt, and now it's the really senior developers who are doing AI code generation. And I really think it's the group in the middle that's struggling a little bit, right? Because honestly, when you don't know what you're doing, AI code generation sounds awesome, right? Like I don't actually have to learn what I'm doing. I'll just use this tool. Oh, thank you so much. Sorry for being so whiny about it. And then when you're like very, very experienced, right, you get to that point where your goal is to deliver customer value, not to write another line of code. And so any tool that will allow you to get there is a tool that's exciting to you. But in the middle, you feel like your identity is wrapped up in your ability to write software, right? And so we're sort of growing with this. We're seeing this inside. We have the same spectrum inside our own team, right, in terms of how our engineers think about this. But we have a decent amount of adoption. We have people that are starting to see where can I change in my process. And we have people, particularly the ones that are thinking most about how our customers are using it, who are very, very invested and really pushing the envelope. And I guess kind of to reference the survey a little bit, we're all over the place in terms of tools that we're using because every different tool that we try teaches us something about the industry and what people are trying to achieve. Oh, that wasn't the thing. All right. Oh, what just happened? Oh my gosh. It is me. It's 100% me. All right. So there are other places. It was actually that I forgot what slide was next. There are other places where we get productivity. So this is like a really simple example, but we happen to be opening an office in Mexico City at the moment, and we're hiring engineers, and we happen to write software in Go. And our local site director, who we just hired, said, oh, we'll get experienced engineers, but we won't get experienced Go engineers. And I said, well, what you would normally do under these circumstances is go read a bunch of job postings of other companies here and figure out who's using Go. But it turns out you just type that into Claude, and it tells you exactly every company in that area that's using Go, and also says, by the way, if you're trying to find those developers, you might try this meetup, and there's this upcoming event that you should consider going to and maybe sponsoring, and you'll find developers. So it's like, first of all, it took 2 minutes, and second of all, it gave us way, way better information. And so we talk about, like, that's an engineering job to me. Somewhere in the engineering organization, we're trying to solve this problem of where do we find great talent. So it's not just I'm generating code, but I am spending time doing things that I don't need to be doing myself, right? And then this is only funny to me, but also very important. This is an argument I was having with Claude about whether or not it can search the internet. And even after I turned on the setting, which it turns out is a setting, it wouldn't listen to me, and so I had to start a new chat. And I just wanted to highlight at the bottom, it does say Claude can make mistakes. And this is really important, though, because your people are doing this and then saying this thing doesn't work, and then going back to doing the things the old way. But if you're just like a little bit patient and use your head, I was like, well, probably this is just a session, right? Maybe if I start a new session, I'll get past the problem. Like, we're engineers, we know how to solve these problems. But you have to kind of help. I think there's a group of people inside your organization who want this to fail, is the thing that I would say. So find the way to guide them past that. All right, so developer experience. This is a 2x2 that I made a long time ago, but it made sense to me, and I thought it was a thing to think about, which is, yes, you can take generative AI and apply it to your product and help people solve their problems, right? But you need to think about where it's actually going to be valuable. Like, at the end of the day, you're building a product for your customers, and you're trying to solve your customers' problems. And the way that I like to describe this is putting more sparkle emojis on your product is not the thing that's going to make them happy. I don't know if anyone remembers the LinkedIn message summarizer under every message, right? My friend just wrote a 3-sentence thing, and there's like half the page is taken up with a box saying, do you want to summarize the 3 sentences that your friend wrote? I'm like, that is of no use to me. And then I actually went to take a screenshot of it, and it disappeared. So clearly they got some feedback saying this is not helpful to anyone, right? But in this particular case, we were talking about in a developer tool, what is useful. And so I love 2x2s because they're simple and they help people think about things. And the 2 axes that I came up with that were worth talking about were the volume of high-quality training data available and the size of the solution space. Right? We talk about generating code because the solution space is unbounded. Right? The number of things that might be useful or possible when writing code is effectively infinite. And there's a decent amount, like judge other developers all you want, but there's a decent amount of high-quality training data available to LLMs to learn. In the bottom left corner, one of the things that we talked about was writing config for CircleCI. All of the great CircleCI configs are in private repositories. They're not available to the LLMs. And the solution space is very finite. So we know much more than a general purpose AI tool does about how to do that one thing. So asking another tool to guess and get it wrong so we can tell you it was wrong is not necessarily a good application of our space. But in the middle, something that we could do that's very helpful, and we ended up doing, is build errors, right? My build broke. It spit out this error message. Somebody on the internet has searched for that error message in the past. Something knows what that is and can give you a helpful solution to go solve that problem, right? So thinking about where do I have opportunities where this is actually a great application is a thing that I would just encourage you to do rather than, again, sparkles on everything. Then our customers change their goals. Our customers are trying to build with LLMs integrated. And so there was a whole discussion about evals. We put a huge amount of energy into marketing, well, I guess marketing to the market, positioning to the market our ability to run evals on their behalf. The only problem is no one actually does that. Everybody ships their LLM-driven code into production and then waits to see what happens. So our ability to help them run the tests they didn't write was not particularly valuable. So then, I mean, I would encourage you, whatever it is that you're doing, you have to rethink how people are operating, right? So what we ended up doing was building a prompt workbench, basically, to allow people to build the things they were YOLOing into production and then give them parameters that they could modify to make it more testable for them so they could make the best use of our product. All right, now I want to get into the last section, which is the one that I'm most interested in, which is that everything's changing. This is where it gets a little galaxy brain. Bear with me. Again, I'm going to try to provoke you so that you'll ask hard questions of the panelists after this. So this is the SDLC as we know it. I mean, it's as simple as possible, right? I'm just trying, maybe you can't see from the back. I was standing back there a minute ago. But design, code, build, test, deploy, observe. I missed review, which actually it turns out is a hot spot at the moment. Again, I'll blame the 130 trying to get these to Ted before I got fired from this. But that actually is an area that is really interesting. And the reason that comes into effect is I really think we're about to learn again about the theory of constraints, right? We are entirely focused on code because that's the bottleneck, right? I mean, unless you have really bad PR review times, which you come back to. But we're about to fix that, and then what's going to happen? Like, I don't think we've really thought about what's next, right? The code cycle, the build cycle, the test cycle, all of those things have been fine because they're so much faster than the coding. But when the coding changes, all of these other things are going to come into play, right? We're rapidly going to put pressure on the system and start to think about where the next break is and where the next break is and where the next break is. And I think PR review is a really interesting example. And so then we're like, cool, let's get all these together, right? How can we merge all these tools in a way that we'll be able to use them all and get like the AI awesomeness of everything? And so everybody built an MCP server. How many people here have launched an MCP server? And how many people launched one on a weekend like Red Bull infused hackathon? So we took all our most critical data and strung it together with a bunch of Red Bull infused hackathons. I don't know who was asking about security earlier, but just like think about that for a second. Also, just quick consolation prize to Claude for its version of that image. I'll go back. That's OpenAI. That's Claude. So I love Claude. I use it for a lot of things, but not for turtles all the way down. Just for reference. All right. So then you get into the most interesting problem for me, and there was a little bit of an allusion to this in a question earlier. So AI, I hear this conversation all the time, right? Everybody's on social media talking about their vibe coding, whatever. I solved this really simple problem. It was awesome. Then I tried to do something complex, and my genie went off on a totally like random direction, and there's no recovering from that, right? What's really interesting to me about this statement is that our conclusion at the moment is therefore we need to wait until the AI is capable enough to do the complex thing, instead of asking the question, how do we make our systems more appropriately designed in order for the AI that we have to deliver against them? So I can't remember who asked the question about the languages. Just for you, last night I asked Claude, what are the attributes of a good programming language? And it's an unsurprising list. You're not meant to be able to read this. Don't worry about it. Ironically, the first one is readability, but that's like code, not size of slide text. Writability, reliability, simplicity, abstraction, expressiveness, right? And then I said, do the attributes of a good programming language change if it's entirely written and read by AI? And Claude said, that's a fascinating question. So good, was it you? I think, yeah. Congratulations, Claude also thinks your question is excellent. A few that I thought were particularly interesting in the points were that formal verification properties likely take precedence over human-friendly error messages. Optimization for computational efficiency might outweigh concerns about developer productivity. And consistent, unambiguous syntax would be more important than syntactic sugar that makes code pleasant for humans to write. There's a whole list. You can have it. I mean, or you could just ask Claude yourself. It'll give you a totally different answer, but it'll be interesting nonetheless. But that notion of like, and I think to that question, I was thinking about this at 1:30 this morning. The concept of even tagging within a programming language intent or writing language that carries with it the intent, right? I mean, we've all gone looking for the git commit or whatever that says, why did we do this thing the way that we did it? And that intent is even more lost when AI is sort of reading and writing. At some point, all programming languages are an expression of human interpretation of what a machine is trying to do. And so ultimately, there may be a point at which the whole design doesn't make sense, but I don't think we're ready to get there yet. Like right now, we want to validate that code is good by reading it as a human, as opposed to finding a more formalized syntax to describe the intent of the code and then ensure that it does what you expected. And then if you think about that, jump to my next thing. This is actually from 2016, which delights me. I read this thing like once a year. You don't need to be able to read it from where you are, but the title is Write Code That Is Easy to Delete, Not Easy to Extend. And the notion is that all the code that we carry is sort of baggage and debt, and it's actually easier to throw things out and replace them. And if you design for that, you'll have a better, simpler design. And the great news is that thing that you're trying to maintain and refactor and make maintainable, if it's entirely being managed by AI, you can just throw it out and do it again. It built that thing in 20 minutes, right? So why is the whole goal to then reshape it slowly over time, if you can specify from the outside how it should work? And then I read this really interesting thing from Kent. Does anyone know who Kent Beck is? He's been around a while, talks about programming a lot. So he's really into what he calls augmented coding at the moment. And he put up this thought. It's from his newsletter. I hope he doesn't mind. You should subscribe to his newsletter there. I've done a service for him. Now it's an ad. But two things he points out. One, coding agents are non-deterministic. We knew that, right? And they're sensitive to initial conditions. So if you put those things together, you have chaos in this description. But that's because we are trying to get them to do software development the way that we do it, which is very linearly, very iterative, and I would do it the same way if I was going to do it again. But it's super cheap to get it to do the thing that you wanted. So if you can define what a good outcome is, let's say, on average, a coding agent's going to do the right thing by your definition 50% of the time. That's pretty frustrating, right? Half the time I have to tell it to do it again, tell it to do it again, tell it to do it again. But if I ran 7 of those in parallel, I'd be over 99% chance that I'm going to get the thing that I want, because I only need one, right? None of us code 7 different implementations at the same time to figure out which one is going to work the best, but I can ask a machine to do that. But we don't think about that. We think, how do I get this thing to behave the way that I behave, right? So I would posit, we are engineers. We have new constraints, right? The constraints are not the way that humans, we spent 50 years at this point or more figuring out software delivery to be as easy as possible for humans to do it. And now we're trying to get Gen AI to do it the way that we would do it. If you think about constraints as being the capabilities and the idiosyncrasies of the generative AI, then you would ask different questions about how to build software. And I think the winners among your teams are not going to be the ones that wait for the AI to catch up and do things perfectly, but the ones that can reimagine systems in a way that you can take advantage of the power that we have in AI today. All right, panel time.